Hello, chemistry. It's time to talk about acids and bases. Acids and bases have two different faces. Okay, from the previous unit, let's get rid of all of this highlighted nonsense. From the previous unit, we talked about the properties of things in solutions. So we're kind of done talking about ionics and moleculars. So this unit, we're going to be talking about acids and bases. Now, of course, you should know that ionic compounds form electrolytes if they're soluble. Moleculars don't. But let's just quickly review the high points and the low points of acids and bases. Acids, strong, form electrolytes. Weak, some electrolytes. What does that mean? That means they form ions. Bases are, if they're strong or weak, it's if they're soluble, they form electrolytes. Okay, so there's a couple bits of review about acids and bases. What pH do they have? What pH do they have? Acids have a pH less than 7. Bases have a pH greater than 7. Now, I'm not going to write down all the different properties, but the big deal of this unit is pH. How do you measure pH? You measure pH by using litmus paper or indicators, and you can also calculate pH. So that's the big rock ideas of this unit. So we're going to start with looking at indicators. Now, you may have used indicators in Science 10 and Science 9. What are indicators? Okay, they change color in response to a reaction with an acid or base. So they're going to change color. Liquid indicators exist in two forms. They exist as a weak acid and weak base. So they're actually a mixture of both an acid and a base. And when they change into an acid, they have a specific color. And when they change into a more of their base, they have a distinct color. If you have an equal blend of the two, you're going to have a mix of the colors. Now, in your data booklet, there is a list of indicators. You hear that? I'm rustling through my data booklet on page 10. And just breaking down a few pieces of the data booklet when you're looking on page 10, because it is kind of confusing. Let's just pick methyl orange. Now, this is on page 10. So pause the video, get your data booklet, turn to page 10. See, magic of pausing. Okay, so you've got your data booklet now. Methyl orange, that's the name of it, methyl orange. Now, methyl orange has a very complicated chemical formula. So what the next bit of the table shows is a cheat of HMO and MO. Now, MO it's not an element on the periodic table. It's a shortcut for methyl orange. This is the acid because it has a hydrogen, and when it loses a hydrogen, it becomes a base. Right beside the formula of methyl orange is the range of pH that it's effective within. Methyl orange has a range of pH of 3.2 to 4.4. So it can test things really good within that range, and then it's kind of a guess below and above that pH range. Right next to that is red to yellow. So what do those colors mean? Well, if I write down the pH range of methyl orange, red means anything less than 3.2 will be red. A pH higher than 4.4 will be yellow. And within that pH range, you have a mix of red and yellow, which I think is orange. Orange. There, I spelled it right. Is orange. Good job, orange. Orange. Okay. So let's try a couple problems here. Just to recap. So we've got orange 4, which is 1.4 to 2.8. So if I look at orange 4 in the data booklet, 1.4 and less is red. 2.8 and higher is yellow. And red and yellow make some other color, whatever the mix of that is. Does that make orange? Red and yellow make green? No. Red and orange. What did I say back here? Red and yellow. Yeah, red and yellow make orange. I'm so bad with colors. Okay, so let's say you had a phenol red solution and you tested something that had a pH of 10. What color would phenol red be? So you look at phenol red. Phenol red has a pH of 6.6 to 8.0. Phenol red at 6.6 and less is yellow. Phenol red at 8.0 and higher is red. So if you tested something with a pH of 10, what color would it be? Well, 10.4 is way over here, so it's red. Okay. What if you had indigo carmine that changed yellow? So that's what this means, yellow indigo carmine. What pH range or what pH would you have if indigo carmine changed yellow? Well, indigo carmine has a pH range of 11.4 to 13. 11.4 and less is blue. 13 and higher is yellow. So all we know is that this is yellow. So the pH of the solution has to be 13 or higher. Using only one indicator has problems. Unless you hit the jackpot and you're testing something that was right in the middle, it's kind of doesn't give you the greatest, the greatest chance of getting the pH right. So a combination of indicators is the best. So let's say we had an unknown solution and we tested it with 3 different indicators. You can use those indicators to start to narrow down the unknown pH's pH. Bromothymol blue is blue. So if we check bromothymol blue, if bromothymol blue turns blue, now I'm going to do the long form of this. So you guys will probably do this faster. Bromothymol blue has a range of 6.0 to 7.6. 7.6 and higher is blue. So the unknown solution turning blue in bromothymol blue, that means the pH has to be higher than 7.6. Not particularly useful. But if we use phenolphthalein, and phenolphthalein has a range of 8.2 to 10, and 8.2 and less, it's colorless. And we test it, and the unknown solution is colorless. That means it's got to be 8.2 or less. So if it's 7.6 or higher and 8.2 or less, the puzzle is starting to come into place. Phenol red is red. Well, phenol red has a range of 6.6 to 8.0. 6.6 and less is yellow. 8.0 and higher is red. Oh, and it's red, so I know it has to be 8.0 and higher. What is our range then? Our range is really narrowed to 8.0 to 8.2. And that, my friends, is hella accurate. And that's the end of this little mini lesson. You guys are going to watch ZDogg and I do a really fun lab where we're testing the pHs of a whole bunch of different solutions.